Hello everyone, this is Sungjae Hwang from KAIST. I am pleased to present our work on an empirical study of security patches in Solidity. This is joint work with my advisor Seokyoung Yu. So what is Solidity? Solidity is a high-level programming language used to implement smart contracts. Smart contracts are programs running on a blockchain platforms. Since smart contracts are programs, they may contain bugs and security vulnerabilities. As shown in this slide, many security issues have occurred in real world, and these security issues lead to financial loss. So the security of smart contract is very crucial. And due to the tremendous interest in smart contract security in both academia and industry, the vulnerabilities in smart contracts are well analyzed and disclosed publicly. Then how many known vulnerabilities are patched by the Solidity compiler? To answer the question, we first collected known vulnerabilities from 5 different sources, including the official Solidity documentation, projects from blockchain companies, and 186 academic papers that contain smart contract in their title and abstracts. So altogether, we collected 40 unknown vulnerabilities from five sources. By checking release notes of Solidity compiler and by dynamically testing our test code, we revealed that 7 of them are patched by the Solidity team and 1 patch is under development. The patched vulnerabilities are shown in this table. All the security patches are adapted from Solidity version 0.5.0, so 0.5.0 should be used in order to avoid known vulnerabilities properly. So given that the Solidity compiler has security patches, do the patches really enhance the security of smart contracts in real world? The answer is no, because developers do not use the latest compiler. We checked whether contract developers use the Solidity version at least 0.5.0. To investigate it, we first collected 55,046 real-world smart contracts from Meterscan and analyzed them. The analysis result is shown in this table. It is surprising that only 1.86% of smart contracts use the Solidity version 0.5.0 or larger. This means that 98.14% of smart contracts are not protected by the security patches in the latest Solidity compiler. This could be a serious problem because the Solidity version below 0.5.0 cannot prevent known vulnerabilities automatically. If developers do not handle them manually, various security issues can arise. So to understand how many live contracts are exposed to known security vulnerabilities because of missing security patches, we developed a static analyzer that detects vulnerable contracts. By running our tools on 55,046 live smart contracts, we found 4,632 vulnerable contracts that have received and sent more than 10 transactions. The last column shows that the total number of transactions of these vulnerable contracts are very high. So this indicates that these contracts have been actively used. We manually investigate these vulnerable contracts to understand the developer's common mistakes and whether the Solidity patches are sufficient to prevent known vulnerabilities. Our manual investigation revealed many patterns of developer mistakes. Due to the time limitation, I will only explain 2 vulnerabilities, the first one and the third one. Please refer to our paper for more detail. The first vulnerability is misusing constructor by incorrectly naming constructor functions. So in Solidity, a constructor is a special function that executes only once when a contract gets deployed to the Ethereum network and gets removed from the contracts. The name of a constructor function must be same as its contract name. The Solidity patch for misuse of constructor is simple. A keyword called constructor is newly introduced, and now developers must use this keyword when they define constructor function. Our manual investigation shows that developers often make typos in constructor names. Here the contract name uses the capital letter O, whereas the constructor name uses the lowercase letter o, which is a typo. Because the constructor name is different from its contract name, the function becomes a general public function, and therefore external attacker can call this function to become the owner of the contract. We call this developer mistake pattern typos in constructor names. Another mistake pattern we found is incorrect reuse of standard contracts. The Solidity team and well-known blockchain company provided verified standard contracts so that contract developer can reuse them to build secure contract. However, we found that developers make mistake in reusing standard contracts. In this example, the developer copied the token ERC20 standard contract but changed only the contract name, not the constructor name. Similar to the previous example, because the contract name and its constructor names are different, the token ERC20 constructor becomes a general public function, and therefore attacker can call this function to gain both coin for free. The current Solidity patches introducing the constructor keyword cannot prevent these two patterns of developer mistakes. The better patch should be released additionally. There are 4 developer mistake patterns for misuse of constructors. For 109 contract vulnerable to misuse of constructor, we manually confirm that 55 contracts are exploitable, and the total number of transactions for this exploitable contract is 64,674, and 13 of them have more than 100 users. We report this vulnerable contract and assign 4 new CVs. The next vulnerability is storage variable shadowing confusion. Currently, there is no patches for this vulnerability. Here we have 2 contracts, standard token and USDX coin contract. The USDX coin contract is a chart contract of standard token. They both have a variable named total supply. So the variable in a chart contract shadows the inherited variable. The problem is that the function bound in the parent contract refers to the variable total supply defined in the parent, whereas the function mint token in the chart contract refers to the variable total supply defined in the chart. So the function bound reduces total supply defined in the parent, while the function mint token increases total supply defined in the chart. We call this pattern the function conflict pattern. We found 6 kinds of developer mistake patterns. These mistakes can lead to many problems, such as confusing owner addresses and referencing null contracts. Among 231 vulnerable contracts, we manually confirmed that 106 contracts are exploitable, and the total number of transactions for this exploitable contract is 292,048. Among them, 26 contracts have more than 100 users. We report contract vulnerable to variable shadowing confusion and receive 2 new CVs. Because developers make lots of mistakes due to the variable shadowing confusion vulnerability, we believe that the patch for this vulnerability is necessary. So in summary, we observed that many developers do not adapt the Solidity patches properly. Our study shows that it is important to use the latest version of the Solidity compiler, and we need more effective security patches than the current Solidity patches because some of them cannot prevent their targeted vulnerabilities. Also, more security patches are necessary. Thanks for listening, and I'm more than happy to take the questions.